Final video. It's 100% complete. And I'm real happy with it. So here's the rotary phase converter, 30 horsepower. There's the pony motor. I have taken off the mechanical fan on the back, and I added this little 10-inch 12-volt fan there, and it's 1,000 times quieter, but I still don't need to run it for this video. Just let it run without. I've got e-stops, on and off buttons all over the shop here. The air compressor is on one for an automatic startup, so when my air gets low, it'll just turn the system on automatically. If it's already on because I'm using another machine, it'll just fire up as normal. But when the air compressor is done, if it's on automatic and nothing else is on, then this whole system will shut back off and it won't use any more energy than necessary. I've got everything balanced pretty good. That compressor still does take a few moments to start up. I've installed a block heater to keep the oil warm, because I don't typically keep the whole barn warm all the time. It's set to about 42 degrees, so it's just under the threshold where the oil's still molasses, and it really takes the motor a lot of work to get it going. So let's see it turn on here. This is mains here. I need to label that one. So that one's a little less than the other two. So I'll open it up and show you inside. Okay. Here's the inside of her. E-stop, run button. Run capacitors, start capacitors. 0 to 1 second timer for the engage the start capacitors. Not only does it engage the start capacitors via this contactor, but then when it turns off, it's a double pull, double throw, and then it sends power up to this contactor, allowing the output of power. So that when the air compressor is calling for power, let me shut this off. When the air compressor is calling for power via that little wire there, when the air compressor is calling for power, it will start this solely by itself. It'll get the pony motor up and running. Then once the start caps are pulled out, which only pull out when the motor's up to speed because it's timed, then the output contactor will turn on, which means now the unit is supplying full power, full voltage on all three legs. Then it'll start the air compressor. So it's only about a half a second, so this one pulls in instantly. As soon as that one lets go, this one pulls in and starts supplying power to the equipment. So this is the main contactor that has all of the signal wires, the e-stops, and everything else going to it. So it is a 240 volt control circuit. So all the wires are fused here, and there's another one back there. So nothing is unfused as it's running through the shop, 240 volt. It's all in plastic housings. I'm not really too concerned about it. They use 240 in Europe, so we just got to quit being pansies here. So when I hit the E-stop or start run button, really all I'm doing is pulling this contactor, and then everything else just fires up after that. I no longer have a use for my VFDs, but I'll just keep them there. They are suitable for 480. This is a 480 volt transformer that I'm stepping up 240 to 480. So if I ever have a use for 240, I can either do that, or I can pass it through this transformer backwards, and then I've got 25 kVA coming through this transformer if I need it for some reason. If I ever need VFDs, I got those, but those are noisy. All the magnetic starters, they don't like the VFDs. They chatter, they overheat. I've burned up a couple of them, so I won't use those anymore. But this is her right here. and reach around, start it up. You'll see these two contactors pull in, a little light on the relay. You get a little flash when the start cap contactor pulls out. It's got some 300 amps going through all of that contactor and everything to get it started up on the third leg. So it takes some energy to get that arc to break. So that's her. So now, shut this off. Well, we'll leave it running and I'll e-stop it. Okay. So right now I've got it turned on here. All the e-stops are in series. So if I hit any e-stop, obviously it shuts it off. To do that, it had to be wired in series. And then it was in series with my on and off switch. This is the only way I could think about how to do this. So all my on and off switches are parallel to each other. But in the end, when it comes up here, before it's fused, it is then ran series with this. So if any of these stops are pushed in, none of the on and off buttons anywhere will work. As soon as I let that guy off, it's going to fire back up. So I'm going to let that thing cool down a minute so that we don't overheat this guy. I mean, it's still cool, but I know the rotor's probably getting hot and the windings are probably getting hot from the starts. So I'm going to turn this guy on. You can hear it. It's not awful in comparison to the mechanical fan. I can tolerate this with the doors closed now. So I just close this little guy. It's in a horse stall that at some point they poured concrete in and decided, well, we'll make that a storage room. I've got another one on the other side that has concrete floors. And then everything else is still horse stalls. I got these last two to take out over here. Bunch of firewood. Slowly giving it to my brother. All the crap still needs to come out and concrete floors need to be poured over here, and got the machine shop over here. Bandsaw, mill, surface grinder, drill press, lathe, horizontal bandsaw, grinder, sander. I finally got both wheels on this guy. That thing's real smooth. That's nice. So now, the switches. Getting sidetracked. So now I've got one e-stop switch right here. Well, it's a power and e-stop, so I can just back up, grab that guy. I have one here. But this one, I can't turn on the rotary phase converter just by itself. Because as you can see, it's on. But I need to get another label to cover up this. But it's a rotary phase converter auto. So if I turn this off and the compressor calls for air, it's not going to turn on. When I turn this on, the compressor calls for air, the rotary phase converter will start up and do that. And then just the compressor on and off in general. The way I needed to wire that up, I believe that it just ended up being necessary, because all this does is actually turn on the rotary phase converter, and this actually pulls in the contactor to start the motor. So then I got this e-stop here will shut off the rotary phase converter. So these two are actually tied to the rotary phase converter, and this one's just for interruption on the contactor. And then we passed one here. So if I'm walking over here and I need to turn it on, I can run here to the mill, drill press, surface grinder, vertical bandsaw. I can just come over here and flick that guy on. If I'm running in this half, I can flick that guy on. That one, you know, for the air compressor, really doesn't get touched. It's just going to get left in on and auto. So, you'll see the lights flicker a little. You may have heard it in the background, but she's up and running now. So now I can come over to any one of my machines and, you know, fire it up. Got power to my panel. Panel feeds out the air compressor and drill press. That was the other thing too, and I was limping along on the rotary phase converter. You know, every motor has a different current, you know, so if I wanted to use it and not overamp the motor, I had to go set the current maximum to, you know, whatever that motor was for. And like I said, it was really not happy with the motor starters. They'd chatter and they'd get real hot. And I actually burned out 2 transformers for this air compressor. I was trying to run this air compressor and I wasn't happy, so I burned out 2 of these little transformers. So now this is the block heater that I just spun up and milled up, I guess. And I got it set pretty high now. And once the oil temp gets up to, you know, 40 C, I'll probably just leave it alone and then reset the set value to like 40. Right now it's just kind of PWMing, stay around 50. And it still swings a lot. I just shut it off. It's been on for a couple hours. And it's still only at like maybe 30. I guess the issue that I ran into was, you know, this is kind of a heat sink now, so a lot of the energy is just kind of being radiated out to the atmosphere because this probe is not in very far at all. It only stops just inside this because the threads only go about a ½ inch inside there. And after that, there's a casting, like a lip, like a machine, like they didn't go all the way through when they punched this hole. So it's a casting. I can't really go any further past the threads of this block. So I'm basically only getting surface contact now. I was hoping to have a long probe stuck in there, and when I was lathing it, I actually had like a 3-inch probe that was going to sit across the bottom of the oil and work a lot better. But you know, this seems to work. It's definitely starting up now. Before it would just sit there and just lug, not at rated RPM. So it was still trying to start. It was pulling somewhere in like the 100 amps, and it's only supposed to pull, you know, 30, I think, when it's running. But she runs good now. So now I got this temporary hosed. I'm gonna get some black pipe and probably run it up around the header all the way around the shop. This one right now is running over to the furnace across the top of the workbench, and then supplies the compressed air for the furnace. I still have not hydrostatically checked this thing, but I have ran it quite a while now at about 75 psi, and it hasn't exploded. So I got the power washer in here. What I really need to do first is replace the petcock on the bottom, because I know it's gummed up and it doesn't really drain really well, so that once I fill it with water, I'll have a way to get it out. Because right now I don't, other than pulling that bung off and just letting it puke all over the floor in here, and I don't want that. So I'm going to hook a good clean petcock up on there, and I'll just run a hose out to the outside, so when I'm done, I don't even take it outside. If it pops, it pops, and then we'll worry about taking it outside. But it'll just make a water mess if it pops, because it'll be full of water. Hydrostatic pressure testing a pressure vessel. Yeah, so right now she's over there, and you can hear the fan more than anything, and even then the fan is tolerable. The furnace in here now, the furnace fan is about equally as loud. Before it would just drown out all the noise in this place. Well, let's just show you that I can hit any E-stop. I'll turn this guy out. No chuck key sitting there, nothing. No. She's on. And she's off. Now this has a magnetic starter. So when I fire this guy back up, did not fire back up. The only machine I have in here that does not have a magnetic starter currently is my mill. That's got it going right to the tumbler switch. Because it's bi-directional, but I can still put a magnetic starter on there. This is the next project, is get my power feed buttons in here. And actually, I want to relocate this whole face panel down here so I can easier access it. So when I'm up here for an hour, you know, this is eye level, so my hands and arms are above my head for a couple hours. It wears me out. I got the cover off of this guy right now, because I was measuring the travel so that I can get a DRO installed. I'm thinking I'm going to put the DRO on my quill, because my quill is one of my powered feeds, and not on my knee. I mean, the knee has an indicator on it. I mean, everything actually has an indicator on it, but these ones I can't zero, so you gotta do math when you're trying to use an X and Y. But your Z, typically I'm gonna set that where I want it, and then I can just use my little 5-inch center dial there for my Z. I'll just put a glass DRO here. I might have to make a new cover, but I want to add all my limit switches. Right now it does not have any limit switches, but I'm also not power feeding. Once I do the power feed, I'll probably add all the limit switches in, so it'll cut the power off to the stepper drivers. So yeah, that's it. The rotary phase converter, 30 horse, big enough to power this guy. So a 12 horse Ingersoll, 12 horse Kellogg, 36 CFM, 120 gallon air compressor. Finally got something that'll work. But it wouldn't work if I didn't preheat the oil, because it's 25 degrees outside, and when it's 30 or when it's 40 in here, it's usually about 30 by this wall. I still have some infrastructure to finish up. Get all these old goat door accesses they had in here buttoned up. There's plywood on them, but nothing's insulated. So yeah, this is just a Inkbird PID controller. It has an SCR. It's sitting in here, which it's only a 100 watt heater, so I mean I probably could have done without the heat sink on the back, but it came with it, so I'm going to use it. So I am going to pause, let some of the air out, start this thing up, and then I'm done. Okay. So, still heating up, just doing its thing. I dropped it down, I heard it click inside the pressure controller, and the compressor's on, right? So it's like enabled. The only thing that's on that you hear now is the fan, which when this thing cycles, that fan don't need to be on, because it only turns on once every 2 hours. So now I'll just go ahead and turn on the rotary phase converter auto, because right now technically the compressor is enabled. It's already calling, but it's interrupted by this. So what's going to happen is the rotary phase converter is going to come on. A half a second later, the compressor is going to try to turn on. That's it. That's as long as it needs to run to take it from 50 to 75 psi. Now, it'll probably run a little longer once I crank that pressure up to the 175 psi that I'll probably actually run this thing at once I test the tank, make sure it's safe. I'm gonna have an auto drain cock timer, like 10 seconds every 5 hours or something. I'll hook that up to the bottom and just run a hose outside or a pan or something. But that's it, man. Got the wire ran up and over the side, top, down the poles, and then these are all daisy chained up and over and down. I'm happy. This is a project that I've been working on for some time now. It's 56 in here.